Hello viewers, I'm John. On today's video section with the White Academy, I'll be teaching you linear differential equation. Please support this channel by clicking on the subscribe button. Thank you. Today's video, we are going to be looking at linear differential equation. And under the linear differential equation, we are going to be looking at the definition, the steps involved, and solve examples under linear differential equation. So the first one is definition, second one is steps involved, and the third one are solved examples. So we're going to start with the first one by defining what a linear differential equation is. Now, what is a linear differential equation? A linear differential equation is simply an equation or a polynomial equation consisting of an independent variables and independent variables. The independent variables are also known as the derivatives. Now, I want to give you an example of how a linear differential equation is. Equation of this format: a0 xy plus a1 xy prime plus a2 xy prime prime up to an xyn is simply a format of a linear differential equation. Now, let's look at the second aspect, which is the steps involved. We have just 3 steps involved in resolving a simple linear differential equation problem. These steps are: 1. You write the differential equation, or you simplify the given problem into the general formats of a linear differential equation. And what's that format? The format is dy over dx plus py is equals to q. So when you are given the problem, you simply simplify the problem to these formats. After you have simplified, you now compare the problem to this general format of a simple linear differential equation. Once it's the same, you now proceed to the second step, which is you find the integrating factor. Integrating factor known as IF by using the formula IF is equals to E exponential integral of P dx. So you will now look for P. From the first step, after you have compared the equation, you will pick your variables P and Q, which are constant or numerical function of x. Once you pick them, you now differentiate. You now integrate P. Once you integrate P, you now get the integrating factor by saying e raised to the power of integral of what? P dx. And that is the integrating factor. Then the last step is to now resolve the final solution by using the formula y times integrating factor is equals to integral of q times integrating factor dx plus your constant of integration. And once you have gotten this, you now simplify to the simplest form, and that will be your final solution to the linear differential equation. We are going to be looking at the third aspect, which are solved examples. And we have an example on the board already. We are going to resolve this example using the steps we have explained earlier. Now, the first thing to do is to simplify this equation to this format. Let the equation be of this format. dy over dx plus py is equals to q. This is the general format of a linear differential equation. So we are going to make this equation look like this before we can proceed. Now, what are we going to apply? We're going to apply our mathematical steps to these examples to make it look like this. Now, let's proceed. The first thing to do here is to divide through by the x. So once we divide through by the x, we're going to have x dy over dx minus y plus 2x squared dx over dx is equal to 0 over dx. Now, if you look closely, you will discover that dx will cancel out. So you are going to have x dy over dx minus y plus 2x squared is equal to 0. Now, what's the next step? The next step we are going to do now is to also divide through by x so that we can have dy over dx. So once we divide through by x, we are going to have x dy over dx divided by x minus y plus 2x squared divided by x equals to 0 over x. And you know our x will cancel out. So our equation will be looking like dy over dx here minus y. If we want to expand this back, we are going to have minus y. And minus y divided by x will be minus y over x. Also, similarly, minus times minus 2x squared, we have minus 2x squared divided by x. One x will cancel that. So we are going to have minus 2x. And 0 divided by x is 0. So this is how our equation is going to look. So to make it look finally like this equation, we'll move 2x to the other side of the equality sign. So when we move, we are going to have dy over dx minus y over x is equal to 2x. Now, you can now compare these two equations. Let me drop it here so that you see it. Our general equation is dy over dx plus py is equal to q. If you look at these two equations, let's call this one equation 2. This is our equation 1. Now, this is equation 1. Now, we compare equation 2 and equation 1. You will see that we have the same thing. We can get our q, we can get our p from here. Now, let's factor out our q and our p. Now, looking closely, you will discover that our p is the coefficient of y, which is minus 1 over x. And our q is what is at the right hand side, which is 2x, by comparing the two equations. Now, we are done with our second step. Our first step, sorry. Our second step is to now find our integrating factor. And our integrating factor is given by the formula if is equals to exponential integral of p dx. So we are going to get the integral value of p, and then we substitute in this integrating factor formula to resolve the final answer. Now, what's our integral of p dx? Integral of p dx is equals to, what's our p? Minus 1 over x dx, which is minus log x. So we now substitute inside integrating factor formula if now equals to e raised to the power of what? Minus log x, which is equals to 1 over x. Okay? Now, let's proceed to our final step, which is the general solution formula for the linear differential equation. It's given by y times integrating factor is equals to the integral of q times integrating factor dx plus our constant. Now, we are going to substitute our values into this the final equation to resolve our final answer. Now, what is our y? Our y is a constant. What is the integrating factor? 1 over x is equals to integrate. What is our q? 2x. Now, integrating factor 1 over x dx plus c. Now, we are going to have y over x is equals to 2x over x dx plus c. So x and x will cancel. We are going to have y over x is equals to 2 dx integral, 2 dx plus c. So when we integrate the right hand side, let's integrate the right hand side. So once we integrate the right hand side, we are going to have y over x is equals to 2x plus c. Now, we have to make our y subject from here. To make our y subject, we cross multiply. Y equals to x into 2x plus c. And y equals to 2x squared plus xc. And this is our final solution to the question given. Thank you for watching.